guys. So we're moving on to kinematics, which is the study of motion. And it was just easier to make a video than like a PowerPoint to tell you about this next experiment. So kinematics is the study of motion. And so from each unit here on out, we are going to observe a phenomenon. We're going to have a model being made for us about motion. And then we are going to take data on it through an experiment. And then we're going to extrapolate that data to the broader outside world. So for this first unit, your model maker is going to be something of this nature. Okay, now this was about $2, $3 at the dollar, not the Dollar Tree, the one that's not actually a dollar. You need, I'll turn it on for you. So as you can see, it's moving consistently. It's not speeding up or slowing down. So you need to procure some kind of electronic device that's going to give you 5 to 6. Now I put it on the table. Obviously we'll be doing this on the floor. You need to procure some electronic device that will give you 5 to 6 seconds worth of movement consistently. Doesn't need to speed up, doesn't need to slow down. Now, if you've got a T-Rex at home, we were joking in class, if you've got a T-Rex at home that can walk or something like that, it can't be one of those wind-up toys because that's going to speed up or slow down. Right now, we need constant motion because that's what we're going to look at first. Okay? Now, in an experiment, we have to pick variables to measure. And a lot of people in class, the first thing that they're going to say that we can measure if we're making observations about this buggy is speed. And speed is calculated, okay? Even in a radar gun or something like that, when it does the lasers, its calculations, we don't want to do a calculation first. We want to take some measurements, okay? So the easiest thing we can measure with our model maker is going to be position, and then time, where it is, the clock reading, where it is. Now, in physics, basically what we're going to do is so in order to observe that something's moving, we need to measure where it is and if it's changed that position in a set amount of time. So that should sound a little familiar. Now, in physics, we have to be able to compare positions, okay? We call it the origin. That should sound familiar. Or we call it the reference point. So you're going to have to pick a reference point at your house. In class, we're going to pick a spot on the floor, and that's where all our data is going to be taken from. The reason we have to do that is when you see a position in time graph, you need to be able to know where that car was in relative spot to something. So we call that the origin. So I'm going to call this table 0, 0. Okay? It's going to be 0 position at 0 time. You can guess where that would go on your graph. Now, in physics, it's convention. So it's accepted that anytime you move to the right or up, or it could be north, or it could be east, we call that moving in the positive direction. And anytime you move left or down or west and south, we call that moving in the negative position. So right now, if this is my 0 point and I turn off the car, or turn on the car, excuse me, it's moving to the right, so it's moving away in the positive direction. Now, if I were to turn on the car from here, my car is so many meters away in the positive direction, and it's moving towards the 0, 0 in the negative direction. And so you might get a visualization of what those graphs may look like. Now, for your experiment at home, and I'll go over in another video later after you get your graph made what we're looking for. But for your experiment, you're going to need a timekeeper, which could be yourself. You're going to need some kind of electronic device, and then you're going to need what I call breadcrumbs. Now, here's the deal. Human beings are horrible timekeepers as far as how quickly we can say 1 second, 2 seconds, 3 seconds. So what I suggest, now, if you've got a lot of helpers at home, then you're more than welcome to get them to help you. But so you can do the experiment yourself, here's what I suggest. I suggest getting you a spot on the floor and putting a piece of tape so you know it's the exact spot. I suggest you getting something like coins. I had paper clips on my desk. And also, so you can be hands-free beside your coins, since we're gonna measure in seconds. So our graph is gonna be position, which will be in meters or centimeters. It might be smarter to do centimeters. Our graph will be position in centimeters, and our time measurement will be in seconds. So instead of having somebody or yourself look at a watch and say 1 second, 2 seconds, because by the time they've set it, it's already going to be like 1.01 seconds or 1.02 seconds. I suggest you download or get on the computer and get a free metronome app. If you're in band or you've played guitar or something like that, a metronome helps people keep time. It uses beeps. If you will set the metronome to 60 BPMs, that app will make a tick or a beep sound every second, okay? And so that way you know exactly when to lay down your breadcrumbs, okay? We wanna know where the car is. We wanna discuss the car's motion. The best way to do it is gonna be the position of the car every second, okay? So time will be on your X, position will be on your Y. Now, I don't have the metronome. I've got it on my phone, but I can't play it and record the video. But here's what you're gonna do. You've got your 0, 0. You're gonna turn the car on. Now, for the record, I'm jumping ahead of myself. You are more than welcome to call me and I will hand you one of these outside of the R-Wing if you promise to take care of it. If you don't wanna go find a cheap one, if you don't have one at home, you don't wanna spend the $2, $3, totally understandable. You don't have a little cousin that has a Reptar, whatever, totally understandable. Get in contact with me, I'll send one of these home with you, as long as you bring it back. Now, the problem is, if you set the vehicle down or the T-Rex or whatever, and you turn it on, there's a split-second delay, okay? And we want data as accurate as possible. So what I suggest doing is holding the car just above the start, listening to the metronome, and then just count down, go 3, 2, 1, go. And you drop the car and it'll start moving. And then every second you drop one of your breadcrumbs. Now I'm gonna imitate it. I don't have the metronome, but I'm gonna do it just enough for you to get the idea. I think you already have the idea. But so we'll go 3, 2, 1, go. 1 second, 2 seconds, 3 seconds, 4 seconds. So obviously that wasn't exactly seconds. But now I can take my data because I know at 0 seconds, the car was at 0 centimeters. At 1 second, the car was, and I'm just gonna pretend here, the car was 38 centimeters away from my point of reference. Okay, so my first point is 0, 0. My second point was 1 second, 38 centimeters. My next point would be 2 seconds, 80 centimeters, and so on and so on. You're gonna wanna repeat the trial because humans are obviously not that great at reaction time. And you need a space of at least 6 seconds, right? Because we want 6 data points. So 6 data points, and you need to do it 3 times. After that, you're gonna graph it on, once again, we already said time on the X and position on the Y. You can go ahead and come up with the equation. By then, I'll have posted a reading for you to do. And then I will post screenshots probably of other people's work so I can explain about what you're looking at. It's gonna be a position time graph in centimeters and seconds. So that's a distance and then a time. We actually are gonna use the word position instead of distance. I'm glad I messed up and said that. When we talk about distance is usually total length traveled. So you ran around the track 4 times, you traveled a total distance of 1 mile. We're gonna be talking about displacement, where I'm at from where I started. That's why we kept measuring from the 0, 0, the point of reference. But that's enough for now. You need to find you or get in touch with me, your model maker. Find you a spot at the house that can give you at least 6 seconds worth of measurement. So that'll also depend on how fast we'll say how fast your model maker is traveling. You'll need a measuring device. Don't forget, we're in the metric system. And then you need a metronome. This is gonna be the easiest thing to take time. Once you get that graphed, you can carry on with this next unit. As always, private comments if you have any problems, and let me know.